On October 31st, 2008, a document was posted into a popular cryptography mailing list. The title of this 9-page document was Bitcoin, a peer-to-peer electronic cash system. In it, the anonymous author going by the name of Satoshi Nakamoto describes a form of electronic cash which the world had never seen before. To understand the significance of this document and why it kickstarted arguably the biggest revolution of our financial system, we have to go all the way back to the origins of money. So, why was there a need for money in the first place? Well, because exchanging goods directly for other goods is pretty inconvenient. You need to find someone that wants the exact good you're selling and can give you the exact good that you need. In other words, there needs to be a double coincidence of wants, where one person wants exactly what the other person wants in order for the transaction to happen. The solution to this problem is obvious to us now. You need to introduce a third good into the system that everyone wants. Ideally, this third good should also be scarce, so that any one person can't quickly produce huge amounts of it. Throughout history, many different things have been used as this third good, such as grain, cattle, shells, and precious metals. One of the most popular ones is gold, which established itself over time as a means of exchange and store of value. However, starting around the 7th century, people began to realize that using precious metals as a means of exchange had a major disadvantage, especially when trade was taking place over great distances. Large amounts of gold aren't that easy to move from one place to another. It also posed a high security risk, since the gold could be intercepted and stolen in transit. The genius solution to this problem was to have a person or institution basically protect your gold for you and give you a contract in exchange for it. This piece of paper would guarantee that you can retrieve your gold when you want it back. Now, all of a sudden, instead of trading gold, people were able to trade these pieces of paper, which of course were much easier to transport, all while the actual gold that it represented was sitting somewhere in a vault. Worldwide trade accelerated, and we came to call these pieces of paper money. The concept where all the money that is being used on the market is backed by actual gold in a vault is also called the gold standard. These institutions or banks that would take your gold and exchange it to paper money and back were initially run as private companies. Eventually, this function was taken over by governments, creating central banks. This system was very successful for a very long time. But the problem was governments were able to abuse it, which came to a culmination in the 20th century. In order to finance wars, especially World War I and II, governments across the world started printing more and more paper money, bringing the whole system out of balance. Essentially, they were creating money out of thin air, which basically means shifting value from the population to the government. The increased money supply meant that the paper money was not sufficiently backed by the gold in the reserves anymore, causing people to lose trust in it. Eventually, the gold standard had to be officially abandoned. This official scrapping of the gold standard happened only as recently as 50 years ago. After that, we created so-called fiat money, which is the money we are using today. Most of us grew up with this type of money and are thus taking it for granted, but it's useful to remember that we are actually taking part in a very new experiment in history. This type of money has value merely because the government says it does. In other words, it's value by decree, and it's solely backed by the respective government issuing the money and not by any other asset in a vault. As the world became more digitalized, consumers wanted their payments to be digital too. Banks began creating technologies like credit cards, debit cards, and online banking, which basically replaced paper money with digital information stored on computers. When I pay someone digitally today, my bank reduces my balance, which is stored on their servers, and increases the other person's balance. No physical cash is moved, only numbers in a database are changed. Even if the other person's account is at a different bank, physical cash is hardly ever moved. While digital money is convenient, it created a whole new problem: privacy. With cash, your payments were private and there was no way for institutions to know what you were spending your money on. They were just pieces of paper. But the combination of digital transactions and banks as central institutions controlling the supply of money meant a loss of privacy for the consumer. This is significant because transactions are the basis of all our economic activity. It governs almost every aspect of our daily lives. Giving institutions the transparency to see them in detail shifts an unprecedented amount of power to a select number of people. History tells us that the balance of power is a fragile thing. Too much power in a few people's hands usually leads to bad outcomes. A group of people very concerned about privacy in the digital age came together and started discussing solutions to this problem. They communicated through an online mailing list and became collectively known as the cypherpunks. The goal was to create some new form of digital money that is not only private, but also not controlled by banks. However, removing banks out of the picture makes this a very difficult task, not just from a political, but mainly from a technological perspective. No one had yet found a way to do this. For something to work as money, it needs to have scarcity. This is one of the functions that a bank fulfills. So digital money that is not controlled by a bank would need to find another way to be scarce. But anything digital is really just a string of bits, a series of ones and zeros stored on a computer. How can they be scarce when it is really easy to just copy them? It helps to stop and really think about how challenging this problem is. Essentially, there were three big puzzle pieces that the cypherpunks needed to solve. First, a way had to be found to make truly scarce digital money. Same way you can't just copy your $100 bill and spend it twice, double spending should not be possible in this digital currency. Second, privacy had to be built into this new form of money. And finally, the holy grail of it all, the solution should be designed in a way that is not controlled by one entity, such as a bank, but rather decentralized throughout the network of people using it, to prevent the same kind of power concentration we have today with banks and the state. The first attempt at solving one of these puzzle pieces came in the 1980s. David Chaum, a well-known computer scientist and cryptographer, developed a technology called eCash. By using new developments in cryptography and inventing something known as blind signatures, Chaum was able to create a currency where transactions were completely private. It worked like this. Let's say Alice wanted to pay Bob privately. First, a bank would issue the eCash currency to Alice. The ID of the issued currency would be cryptographically scrambled, meaning that there was no way to track it. This was made possible by blind signatures. Alice could now pay Bob in that currency, and when Bob exchanges that currency at the bank, there would be no way to know that the payment actually came from Alice since the ID had been scrambled. eCash was considered a big achievement, and it motivated many of the later cypherpunk members since it showed that a private digital currency can exist. However, it still had many flaws. Scarcity and no double spending were only achieved because of the centralized nature of its architecture. Technically, eCash was not a standalone currency since you still needed banks to operate and control it. It was in no way decentralized. The technology eventually did not gain enough adoption, and the company that Chaum founded went bankrupt. The next milestone came with the invention of Hashcash by Adam Back in the late 90s. Although the name suggests some relation to cash, this was actually not its main purpose. It was initially a method developed to fight email spam. The idea was that computers had to contribute some amount of computing power to solve a mathematical puzzle. This was done with a mathematical function known as the hash function. Essentially, it takes an input and spits out a number that looks totally random but really isn't, like this. And if you change the input only slightly, the output will change completely. So if you only see the output, there's no way to find out what the input was, other than trying all possible combinations of letters and numbers and throwing them into the function to see if the result matches your output. The function is a one-way street. Now, for Hashcash, this concept was used and expanded. Let's say in order to send an email, your computer would have to find an input which creates an output that has to start with 10 zeros. The only way to do this is if your computer tries a bunch of random numbers, drops it into the hash function until at some point, by pure luck, the output happens to have 10 zeros at the beginning. Let's say a typical computer would take about 3 seconds to do this, since they can do millions of calculations per second. 3 seconds would be an acceptable time if you wanted to send one email. But if a spammer wanted to send 1000 emails, they would take around 3000 seconds or 50 minutes to do this. So you can see how this turned out to be an effective way to fight spam. But more importantly, what Hashcash essentially managed was, for the first time, to provide scarcity to digital information. Requiring computers to find a number by brute force was proof that they had put in the work to do so. This meant that whatever the computer was now producing was a scarce good. You can think of it like producing gold through mining. You need a bunch of equipment and manpower to mine the gold. This necessary work that you put in to produce gold makes gold limited and thus scarce. In the same way, the Hashcash output was now scarce because you had to put in a certain amount of work to produce it. The scarcity puzzle had been solved. With 2 of the 3 problems solved, the finish line was clearly in sight. The bits and pieces of the puzzle were there. Now the cypherpunks just had to find some architecture that would tie all of these concepts together. The final part was to find a way to solve the holy grail of decentralization. A first design was proposed by Wei Dai, a computer scientist who later worked at Microsoft. In a blog post, he described a design called B-Money. In it, the money creation system would use something similar to the Hashcash proof of work system. Furthermore, he proposed a decentralized accounting system where everyone participating in the network would keep a list of all the transactions. A shared ledger, so to say, that would make the system decentralized. Compare this to a conventional currency where the ledger is held only by the banks. This architecture came pretty close to how Bitcoin was later designed, but it was still missing some crucial parts. Most notably, Wei Dai didn't quite figure out how users would agree on the same ledger. In his system, it would be quite easy to have discrepancies between the ledgers, which meant double spending would be possible. B-Money was never implemented, but it did provide a first draft, if you will, for Bitcoin. The closest ever design to Bitcoin was proposed by Nick Szabo. In 2005, he published a description of a design called BitGold on his blog. BitGold had a lot of the components in place that Bitcoin would eventually have. For example, Szabo described a mechanism where the proof of work outputs would be chained together to create an unforgeable chain. This can be seen as a description of the blockchain that underlies Bitcoin today. However, just like B-Money, Szabo never actually got as far as to implement BitGold. In 2008, in the same year that Bitcoin was created, he left a comment on his BitGold blog post asking if anybody wanted to help him code this up. In that same year, Satoshi Nakamoto, whose identity is unknown to this day, released the Bitcoin white paper. A few months later, he implemented a coded version with the help of another computer scientist called Hal Finney, who would continue to do much of the crucial initial work for Bitcoin. Bitcoin went from relatively unknown to a mass media phenomenon in less than 10 years. Inspired by Bitcoin, thousands of developers are now working on various types of cryptocurrencies. Millions of people are discussing their significance, and governments are starting to take them seriously. The blockchain technology has the potential to flip our entire financial industry on its head, change how we interact with each other on the internet, and give us entirely new ways of governing systems. So far, Bitcoin has withstood the test of time. The question is, will we one day look back at it as one of the most important technological inventions of our time? Hey, thanks for watching. In this video, I really wanted to focus on the historical aspects of money and how they led to the creation of Bitcoin. I also wanted to highlight the people that contributed to Bitcoin's creation, because you hear a lot about Bitcoin, but not much about all of the previous work that actually made it possible. I wasn't able to go very deep on how Bitcoin actually works from a technological perspective, because that would have just been too much for one video. But if you're interested in understanding that, and hopefully this video inspired that, I'm going to link some resources down below.